Hi 242. So in this video we're going to finish up section 13.1 by finding an antiderivative, but a special kind of an antiderivative. So usually when we found antiderivatives so far, we've been finding antiderivatives where we involve this like big plus c thing, right? So that we have sort of all the possible antiderivatives for a given function, right? Where that plus c can be any real number we like, right? When we do that, what we're actually doing is finding a general antiderivative, right? So any antiderivative, when you write it as an expression of x or u or whatever the variable is plus a big C, that's a general antiderivative, right? But if we know something else about the antiderivative, some piece of information about a point that satisfies the function which is the antiderivative or something like that, then we can find what's called a particular antiderivative. And that's the example we're going to talk about today, is an example of how we find what's called a particular antiderivative. My pen is acting up. Okay, a particular antiderivative is different from a general antiderivative, and that with a particular antiderivative, we actually find a specific real number for c. We don't just leave it as a big plus c. We actually find a number, the number that is necessary, I guess, for that problem, right? That actually makes sense and would work for that problem. So let's exactly see how this would work via an example. So let's consider the following. Let's say we have a marginal cost, and remember, marginal cost means it's the derivative of the cost function, right? So if we have a marginal cost of producing x units of some kind of an item, and that marginal cost function is given by c prime of x. Remember, marginal cost is derivative of the cost function. So let's say c prime of x, the marginal cost function, is 0.4 x squared plus 3x. Okay, and we're also given something else. We know fixed cost is $1,400. Well, if you remember from maybe some of your business experiences or classes or something like that, fixed cost refers to what? That's the cost to produce absolutely nothing, right? Okay, those are like if you had to just pay for the building to house where you're going to manufacture the items or something like that. These are costs that you are going to incur whether you make anything or not, right? So if you incur costs, this is going to be at the very least how much you are going to pay, right? It's going to be more given that you're going to have manufacturing costs and labor and all those kinds of things, but this is the very least, right? And I'll say that one more time. If you make no items, this is how much your cost is going to be. Okay, so the task here is to find the actual cost function, c of x, and then determine the cost to produce 100 items. Okay, well, let's first try to answer this first part here, right? Let's try to do this first part where we want to find the cost function c of x. Let's do that first. Okay, if we have the marginal cost function c prime of x, how can we find c of x? Well, that's just doing an antiderivative, right? Because we're given a derivative. This is a derivative, and we want to know how to get backwards, how to undo the derivative and arrive back at what we started with. So let's do an antiderivative here. Okay, so this is going to be our solution. Okay, so in our solution here, we're going to be able to notice that the cost function c of x is going to equal the antiderivative of c prime of x. How do we write antiderivative of something? That's the indefinite integral, right? So we write indefinite integral of c prime of x. And don't forget, we want to include that little dx stuff, because what is the variable here? X is the variable. Okay. So since x is the variable here, we write dx there. Okay, so this says the cost function c of x is equal to the antiderivative or indefinite integral of the marginal cost function. Okay, great. Okay, well, we actually have a rule for c prime of x, so let's just go ahead and plug that in there. So we know this will be the integral or antiderivative of 0.4 x squared plus 3x dx. Okay, Great. Well, we can actually perform this indefinite integral here because, again, we can break it up into pieces and find the antiderivative of each of the parts. Well, if you've been practicing your indefinite integrals, you may notice that you could just think about this in pieces here and just think about this point 4 as sort of hanging around and then reverse the power rule on x squared and then add 3 times the antiderivative of x here, right? So I could just write this as 0.4, that's the constant out front, right? That would be pulled out front of the sign after we split this into two integrals, but we don't have to do that. Okay, so zero point 0.4, and then what's the antiderivative of x squared? That's x to the third over 3. Again, that's reversing the power rule, plus the 3 sticks around because it's a constant. Antiderivative of x is x squared over 2. Okay, but we're not done because remember that's just the antiderivative of there, but we don't have our constant of integration here, right? So we need to add some sort of big, oh boy, should I put a C here or has the letter C already been used in this problem? Yeah, C already stands for something here in this problem, right? Does it matter what letter we put here to denote a constant of integration? No, we can put any letter we like, right? So since C is already being used in our problem here, let's just go ahead and pick another letter that could represent a constant. How about the letter K, right? We could put K. Okay, where k is some sort of real number again, right? So notice this says that this function is c of x, right? This is our cost function, so this is c of x. Okay, c of x equals this thing plus some sort of real number here. Okay, well, in the real world, do you think that the cost function is going to be given by this kind of a description here, right? This says that the cost depends upon x, the number of things that you're going to produce, right? And that's true. But it also says that there's this like unknown k thing here, right? In a real life model, there would actually be a number there, right? And we should figure out what that number is because this is a real problem. It represents a cost to produce some certain items. Okay, so to find that k, that's actually going to be the process of finding the particular antiderivative, right? At this point, what we have in this line right here is the general antiderivative. Okay, so maybe we should write that in a different color. How about green? Will green show up? Let's see. No, maybe not. How about, I know the pink works. Right, so this is the general antiderivative. Okay, general antiderivative because it involves some sort of constant of integration right there. Okay, good. But now we're going to find the particular antiderivative, which means we're going to find what specific number should go there, what the actual number should be. And how do we actually do that? Okay, so let's now find the particular antiderivative. Okay. So to do that, what we need to do is make use of a bit of information in here that we haven't used yet, which is about the fixed cost right here. That fixed cost being $1,400 tells me that I know that if I were to produce no items, the cost is going to be $1,400. Well, if I write that using my math language, okay, I know that to produce no items means x is going to be 0, and the cost to produce no items, right, that says the cost to produce no items is going to be $1,400. Right? That's telling me what my fixed cost is. I can use this piece of information because notice it's a piece of information about my function c, right? It's a piece of information about this cost function down here. And I can use this information to figure out that capital K. Okay? Because what I can do is say, well, if c of 0 is 1,400, then replace x with 0 everywhere in this function, and then find the value for k. Okay, so let's go ahead and do that. So we know, let's see, so if we plug in 0 for x, I'm sorry, if we plug in 0 for x, okay, into the function c, we get 0.4. Oh my goodness, my pen is being really bad. 0.4 times 0 to the third over 3 plus 3 times 0 squared over 2 plus k. Okay, well, and what do we know C of 0 is equal to? C of 0 must be equal to 1400. So what that means is I know that this thing here, this whole expression here, must equal 1400. Okay, because that's C of 0. Good. Well, what happens on this in this side in here, right? This is all number times a 0, number times a 0. That's all 0 right there, right? So this tells me that k has to be 1400. Okay, so my particular antiderivative is now the function c with my particular value of k. Notice I used the word particular. My particular value of k, x to the third over 3, make that a long fraction, plus 3x squared over 2 plus my particular value of k that I have found using the information about the fixed cost. Okay, this is the particular antiderivative, okay, because it involves, look at this, an actual number. We'll try green again. It involves a real actual number for k, right? So that means this is actually the real particular antiderivative here. Good. So notice that this function here, this particular antiderivative, can be used to answer the last part. Okay, we can actually now find the cost to produce 100 items. We couldn't have done that before with this general antiderivative because finding the cost to produce 100 items means plugging in 100 for x. And if I plug in 100 for x here, I'm not going to get out a number if that k is there still, right? But now that I have a function where there's an actual number for the k, when I plug in 100 for x, I actually do get out a number. I get out the cost to produce 100 items. Okay, so for this last part, the cost to produce 100 items is going to be C of 100, which is 0.4 times 100 to the third over 3 plus 3 times 100 squared over 2 plus the fixed cost of 1400. Okay, and then I'll let you number crunch that and figure something out, right? Make sure you include units. That answer will be some sort of dollar amount, right? I'll let you figure that out. And then if you'd like to check your answer with me, you're more than welcome. Okay, on to the video for 13.2.